guys. Hello, programmers. Hello, stations. Welcome to another episode in the series of our Rust learning. In today's episode, we are going to be delving into the world of code comments and control flows in Rust. Basically, flows are about making decisions and looking through our code. So let's get started. Code comments are like breadcrumbs for future developers, which guides them through your code base. In Rust, the preferred style for single line comment is to use two slashes. Just like we've seen in my previous videos, but I'm going to just give that example here. So for instance, I want to add comments to that line, we'll add two slashes at the front and it's automatically commented out. As you can see, this is very simple. Those two slashes tells us to ignore everything on that line, that's line 2. What if your explanation needs more room? But that's in that situation, it is not a problem. We can use multiple lines of comments, but we have to start each and every one of them with slashes, just like we did. So example of this would be something like this. Let's say we have the print hello world in two places. I'll just copy this and duplicate. So we have this, and this, and we want to comment this out. A simple way in which I do this is by highlighting all of them, and on my Mac, I would say command slash, automatically have added um, comments to each and every one of those lines of code. Sometimes in your code, we want to add comments to the beginning of our code, sorry, to the ending of our code, just like in this case. So we can do something like this and say, this prints hello world. Can do this, but one of the most common ways in which most Rust developers add comments to their code to try to kind of explain what is happening is by adding the comments before the code. And that would be something like this, adding the comments to the top of the code. So with this, we have been able to see how simple it is to add comments to code. But also, there's a little taser for you, and it has to do with um, documentation comments. We'll be exploring this in the future, but these comments are like the gold standard for making your code public ready. So let's go over to control flows. One of the most fundamental constructs in programming in general is the if expression, and Rust handles it like a champ. With an if expression, you can tell your code to execute different blocks based on conditions. It's like saying, hey, if this condition is true, do this, otherwise do something else. Let's look at some block of codes which I've already added and commented out, and take a quick look at how we implement if statements, if else statements, and all that in Rust. I'm quickly going to delete this and get this line of code. Yeah, so all right, in case you're wondering how I did that, I actually still did the same command by highlighting all of them and saying doing the command slash to remove the comments from that particular line of code. So what is happening here? What does this line of code do? You can take this moment to pause the video and try to read this code to try to understand what's happening here. But basically, if you watch, or if you've seen my last video, you would understand that the fn is a function, like in Rust how we declare a function, while the main is the entry point of every Rust program. We have a variable on line 32, which is an integer type of 32, and the value is 3. And then we have our if condition, and yeah. So in every if expression, we start it with the keyword if. Basically, what we have here, followed by the condition you want to check, followed by number is less than 5, which is the condition I want to check. In this case, we are checking if the variable number is less than 5. The code block immediately following the if is executed when the condition is true, and the else block is executed when it is not. So let's run this block of code and see what we get. So say I need to save this and run it again. Exactly. So we can see that it prints the first block of code that is immediately after the if statement, and it says the condition was true. And thinking about it or looking at it, you see that the variable is has the value of 3, and 3 is less than 5. So in that case, we have this line of code printed. In a situation whereby we change this to something like, let me say, 10, save, run this code again. As you can see, the second part of the code executes, which says the condition are false. But there's a catch. The condition in an if expression in Rust must be a type of a bool or a boolean. If not, Rust won't like it. So let's look at an example. So I would copy this, comment out the other line of code, comment out this line of code, and add something below here. So say, and I would remove the else part, and also remove the. So if we have something like this, and we try to run this line of code, we're already seeing a squiggly line there showing that there's an error, and thanks to the Rust analyzer and all that. But basically, if we run this line of code, we'll get an error. So let's just go ahead and run it and see the error that we'll get. I'll go run. So we'll get an error. First of all, we'll get an error of mismatched types. And the reason we have this error of this error here stating that this is mismatched type is because Rust is actually expecting a bool, but it's actually getting an integer. And what does this mean? This means that Rust is expecting a boolean, something that evaluates to either true or false. But in this situation, we just passed the number variable to the if condition. And for that reason, we got an error. So as you can see here, it says expected a boolean or a bool, but found an integer. So basically, Rust won't magically convert a non-boolean type to a boolean. So when we run this code, when we run that block of code, we would get an error. But if we do something like saying, say, if it's not equals to 0, we know for a fact that this automatically evaluates to false or true, whatever. So in that case, it automatically evaluates to a boolean. Sorry about that. In that case, this code would compile. So if I save this and I try to run this again, I can see the condition was true. Basically, 10, which is the variable, is not equals to 0. 10 is not equals to 0. So if expressions are incredibly handy when you want to make choices in code base on based on some certain conditions. And we've already discussed them, but sometimes you need more than just a binary choice. Binary choice. That's where the else if comes to the rescue. So let's look at a very, very simple example. So I'll be adding a new block of code to illustrate this. So looking at this example, say we have something like this. So I'll take some time to explain this. So this program has multiple conditions. As you can see, I'll reduce this. Yeah. So this program has multiple conditions, and only the first one that is true gets to be executed. So even if even if 6 is divisible by 2, we don't see that output because the first if condition is true. But be cautious. Using too many if else conditions can get messy. If you find yourself drowning in them, you might want to consider refactoring your code. There's a powerful construct called match in Rust, which we'll discuss later on. It's a great solution for those kinds of um, situation. But here is a cool trick. Since if is an expression in Rust, you can even use it with a let statement to assign values to a variable. So for instance, let's look at um, let's look at something. Let's look at an example. Look at this example. So say so in this case, the number got assigned to a value based on the outcome of the if expression. This is really a handy and elegant um, way of doing things, but remember the potential results from each arm of the if must be a type, be of the same type. Mixing types in this particular kind of implementation would not work. And what I mean by this is that we cannot have a number here and have um, a character here or a string, something like that. So for instance, I cannot have something like this. Let's see, 7. If we save this and run it, yeah. So we'll get an error that said expected an integer but found a string type. So we cannot do that. So that is something that we have to take note of and always remember that we cannot mix types in this kind of situation. It's a no-go for us, and basically it will not compile. So the if arm returns an integer and the else arm returns a string. We cannot mix types. So now let's dive deep into loops. Loops are a way to repeat code in Rust. So we'll explore three types of loops in Rust, or the three types of loops that Rust has to offer. The first one, or the first one we're going to look at, is very simple and it's called the loop keyword. It tells Rust to execute a certain block of code over and over forever until we explicitly tell it to stop. So a very simple example of this is let's say we have something like this. We say loop and we say print Rust is amazing. So if we save this and I'll clear my terminal and run this code, so we see this code runs forever. It keeps running until, in this case, it keeps running until for Windows users it will be Control C, or for Mac users it will be Command C, something like that. So if I do this, you can still, yeah, Control C also for Mac users, it automatically ends the loop. But as you can see, we've looped through this like a whole lot, using the loop keyword. Keeps going until explicitly tells it to stop. So we don't always have to want to break out of our code manually. That will not be an efficient way of building a program or the software. So in that case, Rust provides the break and continue keyword to control our loops. So the break tells the program when to stop executing the loop. Um, we used it when we worked on the guessing game, if you can remember. We used it in that situation to basically, yeah, we used it in that situation. So now you don't always have to manually break out of your program. Rust provides break and continue keywords to control your loops. So the break tells the program when to stop executing the loop. We used it in the guessing game when the user won. If you remember our lecture on the guessing game, which I will be attaching somewhere at the top of this video. For those that has not seen that, you can go ahead and go and see it. Leave a like, leave a comment. Anyways, let's move on. So next, you can return values from a loop. This is a super handy. This is super handy when you need to retry an operation that might fail. You simply add the value you want to return from the break statement And that is it. So let's look at an example. So let's say, so adding a line of code, um, on the line of code quickly. So in this case, we initialize the counter, and on each iteration, we increase it. So on each iteration, we say the counter plus one, and if the counter is equals to 10, so when it gets to 10, we want to, you know, so we in each iteration, we increase it by one. So if the counter is equals to 10, we break and return the counter multiplied by 2. The value returned from the loop is assigned to the result itself. Here, value is assigned to the result. But what if we have nested loops? Um, in that situation, we can label them to disambiguate between them. So loop labels must begin with a single quote, something which I am going to be showing you must begin with a single quote. And here is an example of that. So let's say we have the main here, have something like this. So you can see the single quote here that comments and that shows the multiple lines of nested loops. So in this code, the outer loop is the one we labeled as counting up. So you can see on line 3, it counts from 0 to 2. And the inner loop is without a label, counts down, basically. So the break count up statement will exit the outer loop. So from the inner loop, we'll be able to exit the outer loop. So let's look at conditional loops with while, using while. So continuing our journey through Rust control flow, conditional loops, specifically the while and the for loop. So first off, we'll look at the while loop. It's a very handy construct when you want to evaluate a condition within a loop. As long as the condition is true, the loop keeps going. The moment it becomes false, we break to exit the loop. So here is an example. So in this example, we're saying as long as number is not 0, so we initialized it with 3. So I'm saying while number is not equals to 0, we want to print the number, and we'll say number minus equals to 1. So we decrement each time. So basically what we are saying here is we would say 3, 2, 1, 0, lift off, print this out. So whenever the condition, the number is, not equal to 0, we'll do this. Whenever it is 0, we print this out. So let's run this. So say, can go run. Oh, sorry about that. I didn't save. So I'll save this breakout using Control C, clear, and run this again. Can go run. All right. So you can see we have 3, 2, 1, lift off. But we can do better. And by doing better, I mean using a for loop. It is perfect when you need to loop over elements of a collection. So let's compare the two approach. So here, I'm going to be adding a code for while loop as well as that for the for loop, and we're going to be comparing both of them. So this is a code for a while loop. I'll say, okay, and also this is the same code that does the same thing, but using a for loop in a more simple and easy to read way. And this here, so as you can see, we are saying while the index is less than 5, we want to print this and then increment until it is no longer 5, and maybe you would return something or print something basically. So here we have 10, 20, 30, 40, 50, and index of 0, 1, 2, 3, 4 basically. So while the index is less than 5, I want to say the value is 10. We'll then increment this from 0 to 1, and we'll check again. The index is still the index here is still less than 5, which is 1. So we'll go ahead and print 20, increment this to 2, we'll keep going, get to the next one, print 30, increment this to 3, to the next one, until we get to that condition. So let me comment this out and run the code. I save this and run this code. So we have the value is 10, 20, 30, 40, 50. And when 0 has gotten to 1, we will automatically stop printing anything. So now we've seen this block of code we've achieved this using a while loop. So let's see how this works using a more simplified version, which is using the for loop. So basically, using the for loop, and we're saying for elements in A, we want to print this. So very simple. So we have let A, which is an array of I32s, and we're saying for every element in A, we want to print something. So we can just also clear and run this. And once you do that, we also have the same stuff. Okay, I didn't save, so let me save and that once again. As you can see, we have the same thing. So the value is 10, 20, 30, 40, 50 until it stops running. Now, the for loop isn't just we don't just use it for collections like this. You can use it for all sort of things. For instance, you want to run code for a certain number of times, and like in our countdown situation where we did something with the while loop, where we did countdown, and after that we did lift off. We could do something like that. And a practical example of this is, let's say I'll remove this and let me write this by hand. I'll say, so for I have something like this. So we'll say for numbers, number in 1, 4, 1, 2, dot rev, this dot rev is a reverse iterator. We want to print something. So print line, print the number, and here outside when that condition is no longer true, we want to print line, and would say lift off. Save this and we run this code once again. So we have similar code to what we had before, where we had the countdown and using the the while loop. So we have the same thing. So basically, this rev is a reverse iterator, and usually iterators iterate from left to right. After using rev, it iterates from right to left, basically. So basically, iterating from the highest um, like backwards. So 3, 2, 1, and all that. So so that's it basically for this chapter. You've learned about comments, if expressions, noun loops. It's been a great journey, and we're just getting started actually. So practice these concepts, build some programs, and get ready for the next chapter. We'll be delving into a very unique concept of Rust in our next video, which is the concept of ownership in Rust. As always, like, subscribe, ring that bell notification to keep up with our Rust programming language series. Until next time, happy coding Rustations. Thank you for joining me on this one.